Hi everyone, I'm Miss Koenig, and this is a quick video tutorial on solving algebraic equations. Now I've already put out one video tutorial that focuses on how to solve an equation. This one's a little bit different because it focuses on doing so with rational numbers. So that includes your fractions, your decimals, and some strategies that you can use to solve those. If you're unfamiliar with solving equations, I would suggest checking out another video prior to coming to this one. If you're ready for rational numbers, let's jump in. So let's start with something fairly simple like this. It says negative 4x plus 12 equals 17. Now, as you probably know, when you're solving an equation, it helps to have a line down the equal sign. The goal is to move away from needing that, but it helps you to recognize that there's a left side of your equation and a right side, and whatever you do to one side, you have to do to the other. Now, the goal is to isolate the term with the variable. In this case, it's the negative 4x. That's what we are isolating. To do that, I need to use an opposite operation. So I see that there's a plus 12x. We're adding 12x. The opposite operation for that would be to subtract 12x, and to do so from both sides. Now, when I subtract, the reason why it works is 12 minus 12 gives me 0, and that leaves me with only negative 4x on the left-hand side, which is what we're shooting for. On the right-hand side, we're left with a 5. 17 minus 12 is 5. Now, you might be thinking this has no rational numbers in it, but bear with me, it's coming. So now I look at this and I see that the negative 4 is multiplied by the x, and I need 1x, not negative 4x. So in order to undo multiplication, I need to divide on both sides. Now on the left-hand side, negative 4 divided by negative 4 is 1, so I have 1x, or just x. On the right-hand side, what I have there is a number that doesn't divide nicely by the other number. 5 doesn't divide nicely by negative 4. But if you stack them on top of each other, you've got a fraction. That's negative 5/4 or negative 1 1/4. Either option will do as an answer. There's your rational number. Just a quick look at an equation that could solve in such a way that it uses integers but results in a rational number solution. Let's try another. This example is a little bit more like a common rational number equation. It says 3/5 x plus 1 equals 1/4. Now I want to show you a strategy for solving this equation that will actually remove the fractions from it. And it's kind of a standard way for doing something called clearing fractions and can make solving a problem a little bit easier. So first, I want to take a look at the left side and the right side. I'll put the line down my equal sign just so I have it there as a reminder. Whatever I do on the left side, I have to do on the right. Now, in order to clear fractions, you want to look for your denominators. So I see that I have a 5 and a 4, and I need to find a common denominator for 5 and 4. The common denominator would be, of course, 20. Now, what I'll actually do with that 20 is multiply it by everything inside the equation on the left side and the right side. So I'm going to take that 20, the common denominator, multiply it by the fraction, multiply it by the 1, and multiply it by the 1/4. Now let's show some thinking on that off to the side. I'm going to put a little thought bubble over here just so we can have our thoughts somewhere and organized. So let's start by going left to right. 3/5 x times 20. In order to multiply those, I really just need to be thinking 3/5 times 20. And I can put 20 over 1 in order to make it into a fraction. Now 3/5 times 20 over 1 is a math problem that can be cross-reduced, cross-canceled. The 5 and the 20 that are across from each other can both be divided by 5. If I do that, I get a 1 and a 4. Now when I multiply straight across, I'll see that I get 12 over 1, which is the same as just 12. So in multiplying 20 by 3/5, I get 12, or in this case, 12x, because there was an x with my 3/5. Now 20 times 1, that's easy, thank goodness, something easy to solve. That's 20. Let's do the 1/4. Now, hopefully you already know what 1/4 of 20 is, and using that unit fraction can be really helpful. But if you like to do the cross-canceling and write it all out, that's an okay strategy too. Nothing wrong with that. Now, when I multiply straight across, I will get 5 over 1, or just 5. Now I've done this thing that's called clearing the fractions. You'll notice that I have an equation that no longer has any fractions in it. Let's go ahead and solve. Again, I want to isolate the term with a variable, so I'll subtract 20 from both sides. When I do that, 20 minus 20 is 0, and I'm left with only 12x on the left-hand side. On the right-hand side, I get negative 15. Now again, I want to isolate that x. I want 1x, so I need to divide by 12 on both sides. And that leaves me with, again, a value that can't be divided by the other value. So negative 15 over 12 is not something I can just divide and get a nice, neat integer answer for. However, I can treat it like a fraction. So I can write it as negative 15 twelfths, and both of those values can be simplified or can be divided by 3, which leaves me with negative 5 fourths or negative 1 1/4. Let's try another. Here you'll see that I have a problem with more fractions, but I'll use the same strategy to solve. So I'm looking for a common denominator between 2, 4, and 8. And I know that the common denominator for 2, 4, and 8 is 8. So that's what I want to multiply across. I want to multiply it by the 1/2 x, the 3/4, and the 5/8. So here's my little thought bubble, and I do suggest you have some thinking on your paper. If you're the kind of student that's going to go outside the lines and find the solution to your work so that you don't have numbers kind of floating everywhere, that's a good thing. That can help you keep organized. So let's jump in. 1/2 times 8. Hopefully you know what 1/2 of 8 is quickly and easily. I'll change it to say 8 over 1. I can cross cancel by 2, which gives me an answer of 4 over 1, or 4. So I'm left with 4x for my equation. 3/4 times 8 over 1 again can be cross-canceled. So you'll see I'm doing a lot of cross-canceling in these problems. That's an okay thing. That gives me 6 over 1, or just 6. And the last step is 5/8 times 8 over 1. Clearly here we can cross-cancel nicely. The 8s can become 1s, and I'm left with 5 over 1, or just 5. Once we've cleared the fractions using a common denominator, we're just solving like any other equation we've solved thus far. So I want to isolate my 4x, and I'll do so by subtracting 6 on both sides. 6 minus 6 gives me a 0, so on the left-hand side I only have my 4x. And again, I want 1x, not 4x, so I need to divide by 4 on both sides. That leaves me with x equal to, and then remember, these are stacked. We can call that a fraction, negative 1/4. If you get something that doesn't divide, leave it as it is and call it a fraction. It's not a scary thing. Another way you could write this is in its decimal form if that's a way you are more comfortable. Let's try another. Now here I have a problem that looks a little different. And I want to show you this one both because it involves some rational number thinking, but also because this is a common type of problem that you'll see in math classes. So I have here a whole bunch of stuff divided by 2 equal to 4. Another way to write this would be 4x minus 9 divided by 2 equal to 4. Now you almost never will see it this way. You'll almost always see it this way, but they mean the same thing, and it can help you visualize what's going on in the problem. Now, I need to get my term with the variable. In this case, this whole entire piece isolated from that divided by 2. Now, of course, we're going to use opposite operations, so I'm going to also multiply by 2 on both sides. And what's interesting about that in this problem is that it leaves me with 4x minus 9 on the left-hand side. Dividing something by 2 and multiplying it by 2, those are operations that cancel each other out. Think of an example. If I had, let's say, 10 divided by 2, which is 5, and then I took it and multiplied by 2, I end up back at 10. That's the same situation here. If I have divided by 2 and multiplied by 2, I'm left with just 4x minus 9. On the right-hand side, 4 times 2 gives you 8. Now I'm solving like any other problem. I need to use opposite operations to get that x isolated. I'll divide by 4 on both sides. Now this one looks a little different than the nice 1/4 or 5/4 that we've gotten previously, but it's still a nice answer. So we can either write it as 17/4, or we can think of it as 4 1/4 in its mixed number version. Either answer is correct, neither is more accurate or less accurate. Let's try one last problem. Now the last example I have for you is a completely different kind of rational number. It's a decimal. Solving these really isn't all that complicated, but because it has a rational number, I wanted to include it in this video just so you could see an example. So when you're solving something with decimals, you treat it no differently than you would a problem with integers or whole numbers. So I'll isolate my 2.5x by using an opposite operation or subtracting 3 on both sides. On the left-hand side, 3 minus 3 is 0, so I'm left with 2.5x. On the right-hand side, 10.5 minus 3 is 7.5. Again, I want 1x, not 2.5x, so I'm going to divide by that 2.5 on both sides. That's going to be a very common strategy for your last step in solving an equation. Anytime there's something next to the x, you'll end up dividing by it eventually. On the left-hand side, 2.5 divided by 2.5 is 1. And on the right-hand side, I've got 7.5 divided by 2.5. And in fact, that divides nicely. You can think about how many times does $2.50 go into $7.50. Another way you could solve this is to think off to the side. Here's my thought bubble. Think of this as a fraction and think about what you could do with fractions in order to find something equivalent but workable. We can't have a fraction with 2 decimals in it. That's not a thing that you see. That wouldn't be an acceptable format for an answer. So one way to deal with that is to multiply the top and the bottom by 10. Remember, we do the same process when we simplify a fraction or when we're finding common denominators. So it's allowed as long as we do the same thing to the top and the bottom. And we end up with 75 over 25. When you see it that way, it might be a little clearer to you that 75 divided by 25 is, in fact, 3. And that gives us the answer to this problem. Now, just like in problems with integers or whole numbers, you can check all of your answers in this work. I haven't shown it in this video because it was covered in a prior video. However, you can plug your answer back into the equation and make sure your answer is correct. And I would suggest doing that as often as possible just because it gives you another checkpoint to make sure you're doing the right work and you're getting the right solutions. I hope this helps you better understand how to solve problems when decimals and fractions show up in the work that you're doing. Thanks for being here, and I'll see you next time.